time's up. Let's do this. So, if you missed my class this morning because of the assembly, I want to go over what we did. All right, so what this is saying is, why is this not working? Okay, it's not. Why is my pen not working? That was an epic fail. Okay, hold on. Hold on. What is happening? Why are you no work? There we go. Lit. All right. So what this is saying is, let's change that up. Let's go. This times something gives me this. So you can mentally think, all right, 3 times what gives me a negative 12? It would be negative 4. That's Gucci. Okay. X to the second times what gives me x to the fifth? Well, when you multiply variables, you add the exponents. So 2 plus what gives me 5? It would be 3. All right, and then y to the fourth times what gives me y to the sixth? 4 plus what gives me 6? 2. All right. Easy enough for monomials. When we get into radicals, it gets a little bit more dicey. Okay, so 5 times what gives me 35? We should mentally know that 5 times 7 is. Now say you didn't know what it was. You could even do this. Your end result divided by 5. So 35 divided by 5, that gives us 7 because it's just, the inverse. We're reversing that. So we can use division to help us. Mentally, I'm hoping we can figure out 3 times what gives me 9. 3. And 2 times what gives me 10. Radical 5. That's your answer. But what if you couldn't do it that way? You could use division. So I would take this divided by this. So it would be like 9 radical 10 over 3 radical dose. Skirt. Now you can cancel. 3 goes into 9 3 times. And then in the radicals, 10 over 2, we can do 2 goes into 10 5 times. So you get, again, 3 radical 5, just like before. We're going to do some problems where you can't just mentally do it. All right, well, you can do it, but it'll be a lot more difficult. Okay, something like this. All right, you can kind of think of what you can do, or let's go into this. 40 divided by 5 radical 8. Okay, well, I can cancel 5. 5 goes into 40 8 times. So now we're left with 8 over radical 8. Now remember, we need to rationalize the denominator. So we have to multiply the denominator by something that gives me a perfect square. You could do times radical 8 to get 64, and then you're just left with 8, which is nice. But you would have, that's too much. But you would have to do that to the top also, and then you're going to have to do some more simplifying. So let's go a little bit smaller. 8 times 2 will give me radical 16, so radical 2 over radical 2. Because you can do this because this doesn't change the value. This is just straight up 1. You haven't done anything to the actual problem. So then we have 8 radical 2 over radical 16. Radical 16 becomes 4. And then 4 goes into 8 twice. So we are left with 2 radical 2 as our answer. And just to check, you know what I'm saying, we can do 5 times 2 is 10. 8 times 2 is radical 16. 10 times 4, that is 40. Cool. All right, so practicing division. Canceling these out. Ooh, that's not fun. There's a fraction. Well, remember, it's 8 divided by this nasty thing, a.k.a. we can rewrite it, because this just means division, 8 over 1 divided by radical 14 over 5. Okay? remember, when you are dividing fractions, you can multiply by the reciprocal, aka 5 over radical 14. I flip it. 8 times 5 is 40. And then we get over radical 14. That's not fun. There's nothing that you can multiply to be easier. Now, multiply by radical 14 times radical 14. It's going to be 196, square root of 196, which is 14. So remember, anytime you multiply a radical times itself, it's just going to be the number in the radical, 14. Up top, we got 40 radical 14. Simplify. 40 over 14, they have a 2 in common. So we're going to divide both by 2. 7. 20. So then we are left with 20 radical 14 over 7, and that is your answer. So that's what would go in here, 20 radical 14 over 7. Ooh, another one. We talked about up here how dividing is the same as multiplying by the reciprocal. So let's do that. Okay. So we have 6 over 1 times radical 3 over 3 radical 2. Just to start up, we discussed how we could cancel out top bottom. It doesn't have to be right above each other. 6 over 3 becomes 2 over 1. So then this becomes 2 radical 3 over radical 2. And now pause anytime you need to. You know what I'm saying? I'm going to multiply top and bottom by radical 2. Radical 2. So then I get 2 radical 6. Because 3 times 2. And then the bottom is just going to be dose. Look at this. 2 goes into 2 twice. Well, I mean once. Silly Kyle. Radical 6 over 1. A.k.a. just radical 6. Stir. You're going to try this. All right. If this is on Edpuzzle, I'm pausing it. If this is YouTube, you can pause it and try it. Or you can just continue. All right. Skip. Beep. Done. Let's do it. 18 radical 2 over 2 radical 6. Well, 2 goes into 18 9 times. 9 radical 2 over radical 6. 2 and 2, 6. We got 9 radical 1 over radical 3. No! Silly Kyle, tricks are for kids. Times radical 3 over radical 3. I get 9 radical 3 over 3. Oh, look at this. 3 goes into 9 3 times. So we get 3 radical 3 as your answer. Try it. Pause it. All right, we get 6 over radical 12. Now you can break 12 down if you want, but I would suggest, you can just, multiply top and bottom by radical 3, because that gives us 36. So 6 radical 3 over. This is radical 36, a.k.a. just 6. 6 goes into 6 once. I'm left with radical 3. And this makes sense, even if you do it mentally. 12 times 3 is 36. Radical 36 is 6. Let's do another one. 8 over radical 18. Oh, I was supposed to pause that. Oops. You can pause it if you try it. I'm going to multiply top and bottom by radical 2. 8 radical 2 equals. This is 36, a.k.a. 6. 8 and 6 have a dose in common. So this becomes 4. This becomes 3. My end result, 4 radical dose over 3. That's fun. Yeah. Oh no, a fraction. I'm going to multiply by the reciprocal. 8 over 1 times radical 6. No! Times 4 over radical 6. I get 32 over radical 6 times the top and bottom by radical 6. I get 32 over 6. Whoa. They don't go into each other too nice, but you could still divide by 2. So we divide top and bottom by 2. We get 16 radical 6 over 3. That's it. That's the answer. I know it's not what you want, but sometimes that's the way the cookie crumbles. All right, 2 more problems. So I got an area, and I have a side length. Now, say I had, this was 4, we don't know what this is, and this is 12. 4 times what gives me 12? 3. And the same concept. The area is 12. We divide by 4 because that's one side. We get the other side. Same concept. The area is 32. We have a side 8 radical 6. We divide 32 over 8 radical 6. Okay. And then, wow, this is like very similar to this problem in a way. 8 goes into 32 4 times. So I'm left with 4 over radical 6 times top and bottom by radical 6. I get 4 radical 6 over 6. 4 6 becomes 2 radical 6 over 3. That's the missing length. You try it. This is it. Oh no, Mr. Girk, you gave us a harder one. It's the same thing, man. We've been doing these. We just did a problem that looked like this earlier. Okay? We can do this. All right. 6 and 90 have something in common. They actually have 6 in common. And, wait a minute. Wow, I wrote this wrong. Silly rabbit. Okay, so 6 goes into 90 15 times. So now we have 15. I'm going to simplify the 2 6. So 15 square root of 1. And I know square root of 1 is just 1. I just like keeping it there. Times top and bottom by radical 3. I got 15 radical 3 over 3. This becomes 5. So it becomes 5 radical 3. Done.